Our project is adapt bottom-up approach. The top existing way to design a such building is draw a shape, like a mountain ridges or something. A designer determines the overall shape, and then discuss with engineer. They determine the interior and realizable design. So some design is lost by engineering problem, but when we adapt the Voronoi, the engineering problem is solved easily. In the initial design process, we perform paper modeling to verify the feasibility of our design. And next, we unfold our model using SolidWorks, the engineering program in the mechanical engineering, and then we design a joint to fold our generated model. And then we perform laser cutting using steel in the format. And the format is some kind of plastic-like material can be easily punched. And then we build a steel joint to hold overall structure, and then they fasten with bolts and nuts. And then we assemble this kind of cells. I mean, this is a thin cell. This is our factory, and not mine. It's from in the Incheon, and we weld each structure. We build the two versions of our model: the steel version and the plastic version. The steel version we are welding them, and the plastic version we use a steel joint to hold the structure. And the final model is shown in this figure. We build the 7 cells to test our exterior and show us to verify our feasibility of design. And finally, we extend this kind of Voronoi diagram to lighting device design. We want to unify the design algorithm in exterior and interior, and also the interior device. We use the same algorithm to design the 3 kind of elements of building. And this is the final application of our Voronoi diagram way. During the experiment, we built the 2 versions of our model, the steel version and the plastic version. We extend the steel version of Voronoi diagram cells to a lighting device. The shadow effect from this hole is shown in this figure. In the room, the light projection is also a Voronoi diagram, so it's very seems good, I think. Sorry. So we call this as a point and space. We build our model in mathematically first, and then we implement in the steel, and in the real we realize it. Thank you very much.
The presentation skill is getting more and more interesting as the time goes by, so maybe we have to stay longer today. So, any comments?
This is a very impressive presentation. Congratulations for the work, and especially the
school. So our proposal is Parent Institute Techno buildings. So we adapt mathematical pattern generation algorithm to this building because it is the users of building is mathematicians or researchers. So we want to unify their brain the algorithm designer, and also the interior device and exterior overall form. The room is consisted by one researcher. One researcher is a point, and their room is divided by Voronoi diagram efficiently. It's very optimal to generate this kind of space. Sorry for the missing, but our application is Pattern Design Institute.
I mean, it's very clear in your mind, but just maybe the presentation was something that you can have just to explain a little bit better how it works.
If you take that question one step further, I like the way you talk about it. It's an optimal way to deal with it. Tell me how you optimize your lighting, your lighting, the lampshade.
I like the lampshade.
Yeah. If you're going to optimize it, how are you going to optimize it?
The shape of light. You mean?
Or you said, you tell me.
If someone asks to build a building, they provide a lens, right? So if lens is not a square, if lens is some kind of very complicated shape, that is hard to build a building in that lens efficiently, right? Because it is very complicated shape like this kind of thing. But if we using the Voronoi diagram, so we select a boundary by a lens shape, and then we optimize the room distribution using the Voronoi diagram. So we say optimal in that way of sense.
So how did you optimize your project?
We set virtual lens in our project, and then we distribute a point by number of rooms, 5 or 6. Then we perform the Voronoi diagram to given points and given land boundary, and we confirm that the efficiency of that room space usage is very efficient than the square type or circle type room. So I think that Voronoi diagram is efficient and optimal space dividing algorithm.
Right. So it's a space dividing algorithm.
That way, the optimal in terms of space dividing efficiency.
Okay. So again, I think you are telling me what you have done and potentially how you can process the design, but you haven't really given me any hints except 4 areas in terms of how you consider the real boundaries for you to do optimization. I think that is kind of critical in that sense, because you are telling me there's a universal rule, a geometrical rule, bound by Voronoi algorithm that applies to light fittings, buildings, interiors, furniture, partitions, you name it. You can do everything. Right? And let's not look at potentials. Let's look at reality. Tell me how much you believe in, really you believe in, that actually you can optimize it.
Right. Sorry, this is very the efficiency is optimized by means of given space in the furniture and the building, and that the space is important, but the space is limited, so we want to use that space efficiently, right? Everyone wants to use space efficiently, so
define efficiency.